So I'm welcoming now everyone, and thank you for joining. We have really some awesome guests today. I will just very briefly introduce you, and if you want to add something, please feel free to do so. So we have Hubert Dulay. I'm hoping I'm pronouncing this right. Solutions architect at StarTree and author of the famous, widely discussed and widely quoted book on streaming data mesh. We have a second guest, Ralph Debusmann. Am I saying this right? Kafka manager at Migros, who has been lately talking about some challenges around the implementation of streaming data mesh and how he successfully overcame those. And well, we're going to talk about this today. Yep. And we have Xiangyu, who wears many hats, this time with his head of cloud engineering hat, on behalf of RisingWave Labs. So before we start, I just wanted to say that we were considering this topic for a while, and we're postponing for a bit because we were thinking, oh, let's wait for the hype to fade away. But it seems that the hype is still there, and the streaming data mesh is being discussed and being talked about. And that perhaps this is the right time to gather people who really have something to say on the topic. So welcome again, and thank you for joining us today. So I was thinking that maybe a good thing to start would be to perhaps give an overview of what data mesh is, and maybe just starting with some historical overview, what is wrong with data warehouse and data lakes, and why do we need data mesh?
Yeah, so let me start that off, because I think the best way is to maybe kind of lay out the inspiration of the book, and then maybe we could talk about the details of how to actually, speak about data mesh in general, and then eventually streaming data mesh. So a few years back, I was still working at Confluent, obviously a streaming company. So I'm always going to be thinking always streaming. But when I read Jean-Marc's blog a few years ago, it made a lot of sense to me, because I was most of my career is heads down data engineer, working really late and fixing things that other people tell me to fix, because I don't know. I'm supposed to know that the governance of this data, it, right? So when I read that blog, and at the time I was at Confluent, when I was at Confluent, I was on the pre-sales side. So my first customer that brought up data mesh was just 2 months later after I read that blog. And I fortunately was prepared to be able to speak to it in the context of streaming, being from Confluent. And it helped me, understand what the customer was expecting and what they were trying to fix, as well as how to apply streaming atop a data mesh data platform, right? When I did my research out there, the content that I was finding out in the community around data mesh was very academic, not specific. And that's really the inspiration of of writing this book, is to be able to just give an example of what a data mesh would be in a streaming context, right? And hopefully it's satisfying the pillars that Jean-Marc outlined in her book, as well as her first blog. So that's really the inspiration of the book. And I'll lead that to segue that to what data mesh is. Basically, there are 4 parts, 4 pillars that Jean-Marc defined. There's data ownership, meaning we're trying to become more decentralized. She's taking a lot of the ideas in microservices and applying them to the analytical data plane, and doing the same thing there. And how to do that is really up to the implementer and the designer. You know, it doesn't have to all be batch or all be streaming. Some of it can be batch and so on. So data ownership is really reassigning that data to the owners that really created that data. Then there's the data product. Since we're moving that data back to their owners, that data needs to be productized so that other domains can consume it in a consumable way, the way they need to consume it. And then there's the things that really enable that, which are the self-service services that enable domains to be able to produce these data products, but do it in a way that is that implements federated computational data governance, right? So data mesh isn't completely decentralized. There is a governance aspect to it, which is, governance is always centralized, to allow domains to communicate with one another. So that's basically the pillars of what data mesh is reassignment of data, and then these facilities that allow them to share data between domains. But in this panel, we're going to talk about, I guess, streaming version of that idea. And I'll pass the mic basically to either Ralph or Samuel if you guys have any comments or implement ideas of how to actually implement a streaming data mesh.
Yeah, so I will just for everybody who is newbie like me, I'll just try to kind of help me unpack. So why do we need the centralized architecture? What was the bottleneck with the centralized one before we move to the streaming side of
yeah.
Ralph,
yeah,
you want to
maybe
talk about it?
Let me just so what I think is, first of all, it's not just about decentralization. It's about kind of a mix of decentralization, like Hubert said, and centralization. So, and that's something which is well accepted in the business, basically. So businesses work like this, especially larger ones. They basically have independent units, divisions, which are basically independent, have their own profit centers, they're responsible, they're accountable. But in IT, that hasn't really arrived yet. So IT mostly works like this. So you have centralized teams for example, what I'm doing at the moment, data integration. So, and these centralized teams, they are responsible for too much, essentially. So what they have to do, that's also what Hubert touched upon. What they have to do is to actually know the data, because they're actually working with data from all these business domains which send out the data. So what we do, for example, at what I'm mainly doing, what my group is doing, is to enable data integration. So we have source domains, basically, where data is coming from. So all kinds of parts of the company sending data, and there's target or consuming domains of the data, and they want to get the data. And we are the enablers. So we basically try to bring the data from A to B. But the problem is that we don't just bring data from A to B. We also have to modify data. We have to transform data on the way so that it's suitable for the targets, right? And all these transformations, that's called mappings in the data integration speak. So all these mappings, transformations have to be done by us, even though we don't know about the data. So all the knowledge about the data which we are dealing with is actually in the domains. It's in the source domains, in the producing domains, and it's in the target domains or consuming domains. We don't know it, and the result of this mismatch is that these central data integration teams like ours have to do endless test cycles with those data senders or data receivers to get it right, to get the transformations right. And we're always kind of in the dark, so we don't really know what we're doing. We're just changing some code, and then they say, okay, it's working now, it's okay, or it's not working. And when something changes upstream, for example, then hell breaks out and all these kind of things, right? So the main problem is really ownership of the data. And that should be more in those domains, in those teams which know about the data. And the same happens when you go to analytics. So when you go to the analytical plane, basically. So when you have data in the data warehouse, for example, and there's all these analytics teams having to deal with that data, they also haven't got too much of a clue about what the data is about, but still they have to deal with it. And that's kind of the main thing for me, what I also got out from Jean-Marc's blogs at the beginning, and also from the book. It's basically trying to move ownership of the data and responsibility of the data more to that place where it actually belongs. And currently in most larger companies, that's not really aligned, and it doesn't work really well. So that's data mesh for me, basically.
Samuel,
For me,
one
yeah, I think to get back to Joanna's question, so what is the difference between data mesh and the monolithic data warehouses? I personally think they are from the different levels. So when we talk about data warehouses, they are just a data infrastructure. So they are way below that. So we have the businesses, like Ralph said, we have different business units, and we have the data models and data partitions in the middle. So, and then we have this data warehouse, streaming data platform, and all other infra services below that. So when we compare these two things, we compare data warehouses to data mesh. They are actually from the different level. So it's personally, I think it's unfair to compare those two. But for me, data mesh is more like data partitioning. So it's just as simple as that. You have different business units, you have different data ownership, you have different data products. You have to partition those data to different data infrastructure. Some of them are batch data, some of them are streaming data. Some of them you need to work on the data ingestion, transformation. Some of them you need to work on the batch processing or stream processing. All of those things, the data have to be divided and partitioned into different business units. And in order to enable communication between each other, you have to define the APIs and the protocols. So, and you have to introduce data governance and data security at the same time. So essentially, I think the easy way to understand that is to translate data mesh into data partitioning. If you come from a more like database or data warehouse perspective background, and then you think of streaming data mesh essentially as how we partition or divide those streaming data into different meshes or different partitions. And the difference is that to handle streaming data pretty well, you need to consider that velocity and also the nature of streaming data, which is like it has a big volume, it has a pretty big velocity, and also it's time varying. And also you need to introduce a new streaming data processing technology to handle those data. And also you need to introduce the API that how you can enable other data ownerships to access your streaming data. So yeah, I would say that would be my explanation for those who are interested in this topic. Yeah.
I would go even further, actually. So I don't think it's just about data partitioning. It's basically, so one thing is really the organizational aspect. So that's not technical at all. That's basically how do I organize and how do I set up my corporation and how do I set up the individual teams and the central teams. Yes. And the idea is to actually break down the central teams as much as you can do. And I mean, still keeping some synergies, but break them down and bring the expertise into the domain teams so that they can do more. And to help these domain teams to do more and to be able to share the data, that's maybe even the key aspect. I didn't mention this, but the key aspect is really sharing the data. So you should be able to share data across your organization. So you break up these data silos, right? Good slogan. But you need to, on the one hand, it's really kind of a balance. So on the one hand, you want to make data more decentralized and give more empowerment to the domain teams, which produce the data and also consume the data. And on the other hand, what you want to do is you want to still allow to share that data in the best possible way, so that you can have, basically, if you are setting up a new project and you need data from sources A to A, B, C, for example, then you should just be able to grab that data ingest it and do with it what you want. And that's currently not possible because there is these data silos. And the only part where current companies think these joins of the data basically can be done is actually in the data warehouse, which is, I think, wrong, to be honest. And this is actually my motivation for streaming data mesh, or for the streaming version of data mesh. It's basically to share the data in a uniform way. So you have data ownership, you have individual domains, you have decentralization, but on the other hand, you have a common technology, which is, I think, which should be in the long run streaming, and then share data via streaming, basically. And then, I mean, you can still take that data, ingest it into your data mesh, data warehouse or lakehouse or data lake or whatever. But also, what streaming data mesh enables you is not just to do that on a batch basis or on a daily basis or something, but you can also reuse data from across the organization on basically the operational plane. So that means in operational applications like your mobile app backends or something, right? So, which you can't do when you first dump it all into a data warehouse or into a data lake or whatever you do. You will not want to do reverse ETL. That's a total anti-pattern, right? And that's also what Hubert describes in his book, right? So it's basically about having this, the central shared technology. That's what Zhamak calls, so Zhamak Dehghani, the author of the data mesh stuff, that's what she calls self-serve infrastructure. So that self-serve infrastructure, if you really go as far as I would like to go, for me, it would be streaming. It would be the log, basically.
Thank you, Ralph. Hubert, can we make distinction between streaming and batch meshes?
Yes. And I can't believe you gave me that question.
Of course.
Yeah, there's contention between batch and streaming, and people are asking why streaming, why batch. If I were to implement a data mesh, I would probably implement it as streaming because you're enabling all the other domains with real-time use capabilities and potential use cases, even if they don't have it today, right? But if they do have it in the future and you don't have it initially, streaming your data mesh, it's a lot of work to actually build the infrastructure that provides real-time data to a domain that wasn't getting it before. It was all in batch. I'm not saying that you shouldn't have batching data products. And in fact, if you think about if you're writing a Spark application and you need to source data from S3, for example, you're not going to it's going to be a lot faster if you just source it from S3 than just consuming it from a Kafka stream, right? It wouldn't make sense. So there are always going to be some type of data product that doesn't, make sense to live on a stream, right? But as far as the data that's moving from the operational to the analytical, that's probably something we need to introduce before we continue on. But I would prefer that to be streaming. And if the data is already in the analytical plane, then I would, you have the option of either consuming that from a stream or directly from, let's say, your S3 or your data lake or whatnot. To introduce one of the primary concepts that Xiangyu provided in the book and her blog is the concept of the operational plane. I'm gonna put my hand up here, and the data an analytical plane, right? There's two planes. The operational plane is basically where your applications live, that applications that kind of power the business, right? That bring in revenue, that have they're mostly microservices, right? That are deployed in the operational plane. You don't want to query that data directly on the operational plane. That's why you want to extract it and put it in some analytical plane, and then do your analytical, questions there, or your model training there, or your real-time OLAP databases there, right? You don't want it in the operational place, so you want to extract that. So streaming data mesh really is being able to pull that data out of or source that data out of the operational plane. But those operational planes, there could be many of them based on different domains and regions and whatnot, internal or external facing, etc. So how do we get all those other domains that same real-time data if they need it, right? And it's that stream that kind of creates like a cloud of streaming data between the analytical and the operational plane. But it's not just a cloud, it's an organized cloud, you know, that allows you to navigate, to discover data products, search, and when you find one, you know it's outlined and as all the governance, the schema, the throughput. When I was trying to organize the book, the streaming data mesh book, every pillar was just as important as the others, and I couldn't find a starting point. Like some people would want to start with figuring out what the domains are, but then there's data products. Like, but yeah, I need a data product. Who owns that data product, right? And then how am I going to be able to produce that data product if I don't have the services that allow me to not have to learn all of data engineering to be able to build data products, right? So every pillar was as important. I couldn't find a starting point. So all I did was just go in order of how Jean-Marc laid it out as what the pillars were. But still, there's a starting point at every pillar that you could, you know, you can claim. That was always a hard part for me. So now that we know what operational and analytical planes are, I love everybody's thoughts of where this like mesh really lives.
Yes, Ralph and Samuel, please.
After you, Ralph.
After me. Oh God. Yeah. So I mean, maybe to make things a bit more like lively, I'll just come up with an example. So something which we are beginning to do at my new company here. So it's again about data integration. It's about bringing data, in that case, from SAP systems, for example, but also from checkouts, for example, all kinds of operational applications which we have, to bring data into a streaming platform. So in that case, Kafka, in a way that it's kind of raw data. So it's basically, yeah, the live updates from the SAP databases, some of them, live data coming from the checkouts, live data about change pricing, change product lines, all these kinds of things. And the idea is to bring that to Kafka. So I mean, we don't call this streaming data mesh, so yet, but essentially that's what we are starting here. So we bring all the data to Kafka in a way that it's reusable across both analytical applications. So we bring that to, in that case, BigQuery, so into data warehouse. But on the other hand, we can reuse that data for operational applications, which, for example, you could think about. I mean, that's not yet done, but you could think of, for example, applications like mobile applications, which discover some data from the checkouts about this particular user. It takes in some other data from other systems like even SAP, and brings that together and finds out, okay, let's put up this advert or this discount for this particular customer, right? And we can do that in real time. So that's one of the applications. But you don't have to be real time. So there's other data integrations which we do, that we have target systems, which so far, for example, only get a CSV file every week, right? So that's not really real time, I would say. Maybe, no. Yeah. So some others get data. So far, they get data from some FTP server every day, right? So there's many target domains, many targets, many consumers which don't need real time. But the cool thing now is that you can also serve these customers or these internal customers with a streaming data mesh, because with the power of a streaming database. So I'm coming to RisingWave a little bit now, or materialize these kinds of technologies, because what you could do now is you could have a streaming database like RisingWave listening to the topic which holds the information which these non-streaming recipients of the data want to have. You set up a materialized view, and then you just give this target team the access to the streaming database. They can just send off an SQL statement to this materialized view once a week, and they get the newest data. But they don't have to know streaming. They don't have to be aware of all the intricacies of Kafka partitions and all that stuff. They just send off an SQL statement and they get their data. So that's the thing. So if you once you have really got the understanding that streaming is not just about streaming, but that it's basically downwards or backwards compatible with batch. And once you have the technologies for actually implementing this backwards compatibility, which didn't really exist, I would say, up until last year or this year. I mean, then you can basically regard the stream as just an enabler of streaming, of real-time use cases, but also you can also have weekly updates. Doesn't matter, but it's served by the same stream. You don't have any more duplication. You don't have any mismatch between different, for example, like in the Lambda architecture where you have where you have batch and streaming like running alongside each other, where you always have the problem to synchronize the two. If you just have one log, one Kafka topic basically, or multiple ones, then you basically have, you have basically a very good single source of truth. And I think that this would be kind of the future. I mean, it's not really accepted in many, I mean, not at this radical scale, but I would say that this is actually what should be done. And in this way, data mesh also ties in with Martin Kleppmann's work, right? From 2017, you know, his book, Designing Data-Intensive Applications. That is basically what was his vision. So basically have the log as the basis of it all, and then just derive batch and streaming data products from that. I mean, it's very radical, sorry.
There's actually a couple of good questions in the Q&A.
Oh, let's answer them.
Yeah, we have a lot of questions, like answer some of them.
Yeah, let's be a bit more interactive.
So who wants? Samuel, can you read those?
You want me to read the questions? I was hoping to answer your questions.
It will be cooler if some of you would be like that. Okay, so the first one, how does data mesh compare to enterprise data catalogs?
I'd love to take this one first, if you don't mind.
Go ahead.
Yeah, so the data catalog is, I believe, is a huge requirement in a data mesh. It's what organizes the data products out there. So what enables you to discover and find the requirements that you need for a specific data product, right? It allows for, you know, feedback to the data product owners, you know, especially say, you know, if I'm consuming a data product, I'd like to know if, I mean, if I start to consume it, that it'll be able to serve being with the same SLAs that it did before, when it was only, say, like 10 consumers, right? Well, adding another consumer, break it, right? Do, you know, all this kind of like, when I hear about data products, I just hear schemas, you know, and ACLs, you know, all the things that are like security and metadata, right? I think there's a lot more metadata that comes with a data product, and data catalogs are extremely important to be able to relay that to the consumers. You know, what's the throughput? You know, what can I look at the lineage? So I'm looking at I'm consuming the right data products. Are they actually, are they derived from the right places that I'm expecting them to be, you know, coming from? You know, these are questions I need to trust that data. You know, Jean-Marc really talks about trusting the data. That trust actually gets propagated all the way down to the analytics themselves and the people that are consuming and making business decisions, right? At the end, you have to maintain that trust from all the way from the source of that data, and data lineage, in my opinion, is a huge factor in being able to gain trust in that data, right? If making sure that it's not crossing like GDPR boundaries, right? Like a lot of that stuff I need to be able to know. I don't want to get in trouble for using this data. I don't want to fail. I don't want my applications to, to fall over if it doesn't have the right, throughput. I'd love to see all of that metadata. And it's really hard. There's not a streaming data product or streaming data catalog out there that really provides all that information. Even if the data catalogs you see today that are primarily batch-based don't have all the required data product metadata that you need to be able to feel confident and trust that data, to be able to propagate that trust all the way down to the true business decision, the people that make that decision for the business, right? So it's extremely important to have those data catalogs, be able to provide all of that data for the analyst to have that trust, in my opinion.
Thanks, Hubert.
Yeah.
Let's take two more questions and then let's continue. So the second question is, how does event-driven architecture align with the principle of streaming data mesh? What are the key differences and similarities between the two concepts?
I can take this one. So, yeah. So before answering this, I would like to elaborate more on the previous question. I mean, the one before that. Yamana's question on the difference between batch and the streaming data mesh. And thanks, Ralph, for mentioning RisingWave in this space. And this actually reminds me of our two use cases. I mean, actual use cases. The first one is, so for example, we have a customer that has thousands of operational databases, I mean, in a traditional way. So all of those operational databases are emitting events, which are basically change data continuously. And well, they are not using any kind of data mesh fashion, but they do want to introduce some centralized lakehouse as the single source of truth. And in between, they want to use something like RisingWave, actually RisingWave, to do the streaming ingestion and also transformation and also real-time views for the business insights. But this actually, they are not using any, like I said, they are not using any terminologies of data mesh or streaming data mesh, but it actually reminds me how they can benefit from this concept. I mean, they have all thousands of like operational databases and hundreds of business units to work on those kind of applications. And if instead of, for example, if they're using batch data mesh, where they will share at least the DWD model of the data, if they're using the streaming way, they can share the data, the raw data, the data even before they're entering a data warehouse and become the ODS layer. I mean, the data way beyond that. So before they are getting transformed, they can share this view of this changing data. They can share it between teams. And this is where actually a streaming platform or streaming pipeline or streaming database can help. So, and this also reminds me to another use case. For example, they're using RisingWave to capture the real-time events, and they're ingesting the events continuously into this streaming database. And then inside this database, they actually use the traditional modeling way to, for example, when they name their data sources, they're giving them the name of ODS layer. And then after they do transformation on this ODS layer data, which are basically raw data, they name it the DWD data. And what if they share this ODS data among different business units? Then they are basically sharing this dynamic data instead of the static data, which were traditionally processed in the batch processing. So I think that would be the difference. And getting back to this question, how does event-driven architecture, EDA, align with the principles of the streaming data mesh? I think, so for streaming data mesh, the key concepts would be how to, not only do you ingest and transform and process those data in a streaming way, but also you're gonna share those streaming data. And for EDA, basically everything is changing. This is actually one pillar or one property of this streaming data mesh. So there are many ways you can implement streaming data ingestion and processing. For example, you can use Spark streaming. You can use Flink, you can use RisingWave. And the difference between those streaming processors, or some of them are batch driven, some of them are event driven. For example, RisingWave provides this capability. For example, whenever you have this event coming in, you can do some incremental processing on that event based on the materialized view, the DAG job that you predefined, and you can have this result instantaneously. And with this consistency guaranteed, so that the consistency between ingesting and reading this data are guaranteed. So that makes it much easier for you to share this data or the view among different kind of groups, so that you can achieve data consistency, which is a very important property of this data mesh concept. So I think if you're using a streaming data mesh architecture in this data modeling layer, and then you incorporate some event-driven architecture like Kafka, like Pulsar, like RisingWave as this event-driven database, then you will enhance this streaming data mesh concept in a much more extensive way. Yeah, so I think that would be my answer to this question. Hope it helps.
Thanks. And the last one before we move.
I could also, I mean, maybe add a little bit to this answer. I mean, so almost completely agreeing this time. So I think, I mean, for example, when you look at event sourcing, which is, I mean, one of the typical event-driven architectures, so you use event sourcing in your application, like you write out all the events which you get from your application, from your UI, for example, you write that to some streaming platform or an event store, and then you recompute your database in a way from these events, right? And I mean, if you think about event sourcing and data mesh, the similarity is, for me, is, I mean, kind of that data mesh is like just a larger than life version of event sourcing. So basically, what you actually do is you bring event sourcing from all kinds of domains into the same event store in a way. So that would be the idea. So like Samuel said, like this company is doing, like this customer is doing, that should be the ideal way. So you have your operational databases, you do CDC, change data capture to get all the events from the databases, which is very similar to having event sourcing in a way. And you bring all these change events basically to the streaming platform, and then from then you can basically derive anything, because you have the whole history of all the changes. You can derive all kinds of downstream derivations. You can use it in all kinds of databases. You're very flexible. So that's maybe also an answer to this question.
Okay, and the final one in this part. Can data mesh combine data streaming technology like Apache Kafka with cloud native data warehouse or data lake architectures from Databricks and Snowflake?
Who takes it? I have
I'm
talked
nodding and
so much already.
Yeah, no, I could take this. Yeah, so if you think of like Databricks and and Snowflake, first of all, a lot of these like data warehouse vendors and data lake house vendors, they are obviously adopting more real-time and streaming capabilities, right? If you think of like Delta live streams, or I mean live tables, they all, you could do Spark structured streaming on top of them, right? Data coming from a data brick or from your lake house or whatnot, your stream can actually be, doesn't have to be on Kafka. It could be just on your, say, Apache Hudi cluster, building data products that way, combining your S3 data with, say, Kafka data that was sourced from Kafka, right? So that's a possibility. Other ways to be able to bring in like historical data with real-time data is your OLAP, your real-time OLAP databases. I come from StarTree, we do Apache Pinot. It has the ability to be able to bring in your historical data from, say, S3 or your data lake, and bring in and consume directly from Kafka, and marry the two together to build a synchronous data product that you could consume from an application. And you would have to put that in, it's like register that as a data product in your data catalog, and then be able to consume that way. There's also the idea of replicating data. Let's say your data lives in the APAC, for example, and you need to use that data in EMEA or Americas, and your real-time data is set by regions separated by vast continents, right? At some point you're going to you can't write a data pipeline that spans multiple regions, like half the globe. You need to be able to replicate that data locally so that it's more performant, understanding that there's going to be a lag in that transformation. That transformation could be real-time data, it could be data in a data lake. So it's really up to you how you want to be able to streaming and real-time streaming data almost implies at the end some real-time visualization to it, and those are typically performant, and they need the data to be more local. You don't want that spanning across multiple continents and regions. So the more local they are, the more performant in real time they feel, right? So in that aspect, you may need to be able to replicate some of that data across, your S3 data to another, even, multi-cloud use cases, right? A lot of people like to deploy their applications in AWS, but then the data scientists like to use their data, like to use BigQuery and GCS. Is that a data product? How do you replicate that data between those and, those cloud providers? So I'm not providing an answer here, but there are many ways to be able to marry real-time data and what we call batch or historical data.
I guess another question for Hubert in this is that, do you think in a streaming data mesh, will Kafka be the only architecture, or we're going to have streaming and batch anyway? They coexist.
I see that as a. This is funny because Ralph and I had just had this conversation.
Probably more radical, so I can also answer this later. Lambda is not an option, but
yeah. This is what I would say is that there is a debate, between batch and streaming. I think honestly, streaming databases like RisingWave, like Time Plus, like Materialize, actually marry moving data with data at rest, right? Streaming databases store data typically at rest, with typically associated with batching, right? And then streaming data, and you're able to just use them seamlessly as if it's just data, right? I see the two types of data starting to converge more together at the end. A lot of products are trying to marry the two types of data. Again, as I said, Snowflake's adopting real streaming technologies, or streaming like technologies. I don't want to get officially call it streaming just yet. And sorry,
Databricks as well.
My headset just died. And then Databricks and the whole lakehouse concept is that's another way of marrying the two. I think there's multiple answers to this, but they are starting to converge. What's really interesting, and I see, is that the whole analytical and operational plane are still going to be existing, but the middle is what's fascinating to me right now, right? The streaming databases really make it nice to have both worlds at the same time. Analytical databases or analytical planes, lots of batching processes there. Operational plane, lots of event-driven architecture there, right? And when you start to marry them together in between, and you need to organize that data in some kind of catalog, you know, a Postgres interface or a MySQL interface on your data, that's the streaming database in between with a view of both operational and analytical is a really interesting idea, right? I think there's something in the middle there, and I love the way you know, streaming databases can actually provide a way to easily create streaming data meshes in the middle, but it would no longer be just streaming, right? It would just be data mesh back again, right?
Yeah, exactly. That's what I think. So that's really important. That I think because what I think is that there shouldn't be really a divide between streaming and batch. I mean, there will still be for some time. I mean, to be realistic, but if you really take this more radical approach and you first put data on the stream, then that's really the enabler is really streaming databases here. Then you can really make use of that data in any form, right? You can use it still in streaming, so you can consume it directly from Kafka. But as I said in this, I told you in this example, basically you can also use the streaming database to basically give you a batch view of that, right? And you don't even notice. So you just connect to Kafka, set up this materialized view, and then you are in the database world. And you can just use some employees which have just been using SQL databases and they don't know about streaming. So that's really that's kind of the enabler. I think that's what's actually enabling streaming to get into the mainstream. I think. I mean, it's quite disruptive actually. Maybe you don't even know that yet at RisingWave, but I think that's kind of the thing. So you, I think that streaming databases really kind of finalize this bridge, which is in your background, Samuel. So, so that's the bridge between streaming and databases, and or yeah, makes that distance right very very short. And that's really important. So I think in a couple of years' time, we won't talk so much about streaming versus batch. I mean, it will be streaming most of the time under the covers, but you won't even notice it. Right.
Okay, but I won't let you turn this into another batch versus streaming discussion.
Oh.
Because that can last forever. But I would like to hear, Ralph, given that you were talking about these challenges into implementation, like some of the real world examples, maybe Samuel has some recent ones. We don't have much time and we have more questions. So maybe we can just like give people like, you know, what's the latest developments there? What you guys are encountering?
To me, maybe just short. I mean, I think one of the biggest challenges is really that the stream databases are so new, so that I have problems to convince my superiors of them because they say, "Oh, it's just alpha, it's version 0.19. We want stuff which is older or which is more mature in some way." So that's a problem for me because I think so far the problem really was that streaming was almost unusable for normal people, for like streaming experts, right? And that's what's changing now with streaming databases, but they're so new still. So that's one of my key problems.
Yes, I agree. For example, if you, as a developer, you want to iron out some personal projects or open source data, you want to do something in a real time or streaming fashion, it's not that easy to get. I mean, most of the data out there are still batch based, they are static, and you want to introduce some OLAP or data warehouses to do this data processing. But if you want to revolutionize your data architecture into a streaming way, you have to reform it from the first beginning. You have to reform it from the data source. You have to introduce the streaming. Then you can introduce streaming processing and streaming and serving at the same time. So I think it's still has a long way to democratize this concept.
Okay, we have 7 more minutes. We have lots of questions. I just want to like, before we kind of like wrap up this part, I just wanted to ask you about this, something I think that was mentioned earlier, and I find this like the most intriguing, this organizational aspect, non-technological aspect, how the concept of streaming data mesh is really about also like decentralizing and empowering data teams. So anybody wants to comment on that? Or we're moving to, we have like a lot of questions.
Yeah, I mean, absolutely. I believe data products really empower any type of domain, that every domain is going to be consuming data at in some capacity, right? Being able to, you know, break down those silos and be able to, you know, find the data that you need to be able to answer the types of questions that your domain needs, without any, you know, red tape or barriers. If I can request access to a data product in a really elegant way, and the next day I'm able to consume it, it does empower people, right? Or domains in that sense.
Something to add, or we should jump to the questions?
Questions. Let's jump.
First one, in a streaming data mesh, how are data dependencies managed across different data products and team? How do you ensure that changes in one data product don't negatively impact others?
All right. I'll give my 1 minute or 2 minute spiel on this one. So when I was writing the book, I did read Jean-Marc's book to make sure that I was complying to all of the pillars. I mean, but I wanted to make, you know, but not, I didn't agree with everything she said, you know, because a lot of it that you can actually do in streaming. And one of the things is being able to make like composite data products from your source and some other domain source. She like wants you not to do that because it's too complicated. In my opinion, I don't think it's really that hard. If I were able to just go into a data catalog and say, hey, I want this one, how can I start consuming it? If I can get the information that I need in my like if it's sourced by Kafka, you know, I can get that data into my own domain and start joining with it. It's really easy. In that sense, it doesn't limit me to be able to make more, you know, composite, more complex data products that other domains may need, or even myself may need. Like if I'm creating a data product just for myself to use and for others as well. So it may be a lot harder of a task to do with batching data, you know, or historical data. But definitely in tools like RisingWave or you know, some SQL based like Flink SQL, all that stuff can really enable you to be able to source data from other domains and then join, transform, aggregate them to create a materialized view from some serving layer. So that's my 2 minute opinion on that.
Anybody else to add something on this one?
I think Hubert is right. I mean, that's a
Okay.
thing that which you can really do with streaming databases and also like stream processing systems like Flink SQL, or I mean Decodable, all these.
So next two are more like statements, or at least the first one. I feel that streaming versus batch is not really the right question. They're both ways of processing data, so we can kind of agree on that. And perhaps the different discussion is about data in motion versus data at rest, how to process both in a coherent and efficient approach.
I think we covered that a little bit, right?
Yeah, agree. Yeah, the next one is interesting one. How can event streaming platforms add value to data mesh architecture?
So well, they're the underlying thing, right? But,
yeah. There are, here's the thing that I don't think a lot of people really think about with data products. In my opinion, there are two types of data products, even in streaming. there are synchronous data products and asynchronous data products, right? Synchronous data products are like the request response, like I invoke a query, I get a response back, but it's a bounded result, right? I don't, I'm getting an aggregation, or like what's the account of something or whatever. Those are synchronous data products. As a request response, and you're not waiting for it in the background. Synchronous data products, things like that are sourced from a streaming platform, are are obviously asynchronous. I'm running an application consuming data from a Kafka topic or Redpanda topic, and I'm able to process it that way. So there are two different types of data products. It's not really spoken about a whole lot. I think in the batch world, there's always going to be a synchronous data product because they deal in batches. Batches have a start and an end, right? So are synchronous data products. There's a start and an end to them. Asynchronous data products are only really live in a streaming data mesh or streaming technologies, and it's what enables you to really like be more real time. If you have a data product that's like asynchronous, and I have to push that into a dashboard, and then I'm like constantly polling that data, right? If I can have it pushed to me asynchronously and using like server-side events or WebSockets and populating, that's a more efficient way of getting data products, right? And displaying them in your whatever application you're using. So it's important to really think about that. And really, you only get that with a streaming data mesh. You can't do it with like a batch only data mesh.
Anyone wants to add something? We're out of time, but would you be okay to stay a minute or two more?
Sure, absolutely.
Oh.
Okay, we have next one. Does the rise of data mesh means impending data of data fabric concept, or can the two coexist? Who wants to take this
I have to
one?
reread that one.
Actually, folks, I do have a meeting, I just realized, but enjoyed the panel. I'm looking forward to the next one, Yolanda. And
many thanks, Hubert. Many thanks for
Oh,
joining.
the death.
yeah,
Thanks,
see you
Hubert.
guys.
Okay, so the death of data fabric. I mean, I think more or less of data fabric as a subset of the data mesh principles. I mean, more or less, it's very fuzzy. I don't think so. I think most of the concepts from data fabric will also be in data mesh and also in streaming data mesh. I mean, streaming data mesh is basically nothing too different from the ordinary data mesh. And also, I mean, many of the concepts we talked about already, data catalog, for example, data lineage, all these things, they should still be there. They are required. I mean, it's especially data cataloging, data governance, that's really things which are extremely important. On the other hand, I think many people think of, just think about the data warehouse in a way when they talk about data mesh and just about data fabric, data mesh, but it's always in the data warehouse. It's always already on this, what Jama calls analytical plane. I think that data warehouses are just one consumer of the data. For me, I would say it's not the single source of truth. It's not the only consumer of all that data which you collect. You collect that data on the stream in the log, and then you have, and then basically data warehouse just becomes an application, basically, which takes data from the streaming data mesh and does all the dashboards for the management in a way. So that's how I think of it. So yeah, it's maybe a bit radical.
Samuel, your thoughts?
Yeah, I think data fabric was a bit older term, and I think data fabric is more an architecture concept. For example, for data architects, that you want to deploy a whole data pipeline, and that data pipeline exists in different from different cloud or from different data centers, then you can integrate all of those data infra together as this data fabric. And I think data mesh is again it's more business. It's more related to business units. It's more related to how you put the different data and think of it as a data product, and you put it into different meshes, and you how to get access and share this data from different orgs or business units. Underneath, they can use different architecture to implement that. They can use data fabric to implement that, but I think they talk about different levels. I think for in order to better understand data mesh, it's better to just focus on the product attribute of this data. So you have this valuable data, no matter it's data in rest or data in motion, you're going to share it, you're going to protect it, you're going to govern it. So this is how you're going to focus. But for data fabric, you're going to focus more on deployment and the data engineering part. So, yeah.
Thanks, Samuel. Okay, let's wrap up this today. We have one more really long question, but I'll make sure that gets addressed in an email. Many thanks for staying. Many thanks for joining. Hope to see you soon as guests on some other streaming stories. Bye, everyone.
Bye.
Thanks a lot.